In this video, we are going to look at the question 10s for the June CSEC math exam for the years 2022 to 2019. So here we have our first question, which is question 10 for June 2022. We have the transformation matrix A, which is 0, -1, 1, 0, which represents a rotation of 90 degrees anticlockwise about the origin. And then we have the transformation matrix B, which is 0, -1, -1, 0, which represents a reflection in the straight line with the equation y = -x. So for part 1, we want to write the coordinates of P prime, which is the image of the point P, 7, 11, after it undergoes a rotation of 90 degrees anticlockwise about the origin. So P is going to undergo a rotation of 90 degrees clockwise about the origin. So that's this transformation matrix we're going to be using here, because this represents a rotation of 90 degrees anticlockwise about the origin. So you know the general structure of this is you take the transformation matrix multiplied by the object coordinates, and you would get the image coordinates. All right, so what I'll write is my transformation matrix A multiplied by my object coordinates, which is P, would give you my image coordinates, which will be P prime. All right, so my transformation matrix is 0, -1, 1, 0. I'm multiplying that by my object coordinates P, and I'll write that as a column matrix. So instead of 7, 11 like this, I'll have 7, then 11 like this. Okay, so that will be equal to, we know when we multiply matrices, we multiply rows in the first matrix by columns in the second matrix. So that's the rows here in the first matrix by this one column in the second matrix. So for the answer, this row controls the top, this row controls the bottom, and of course this column here controls the single column for the answer. So I'm going to have 0 by 7. So that's going to write out 0 by 7 plus this -1 by 11. Okay, so that's my first row here. Then going down with this second row here, the 1 by the 7 plus the 0 by the 11. Okay, so we just work that out. Anything by 0 is 0, so 0 by 7 is 0. And -1 by 11 is -11. And here 1 by 7 is 7. And 0 by 11 is 0. All right, so we're just going to have A times P is equal to, this here will give you a -11. And 7 plus 0 is 7. All right, so this would be P prime. So P prime, the image, would be, I write it as a row now, -11, comma, 7. So that's the coordinates of P prime. All right, so moving on to part 2 now, we have T is the combined transformation of A followed by B. So we have transformation A taking place first, which is this matrix, followed by transformation B, which is this matrix. We want to determine the elements of the matrix representing the transformation T. All right, so we just want a single transformation matrix that will represent A followed by B. Now, the way this works, I know you're seeing A, then B, but when you're doing the matrix multiplication for this, you have to go from B first, then A. So it will look like this. Your transformation matrix will be the matrix B multiplied by the matrix A. And that will represent the transformation of A first, followed by B. All right, so let's think about a little twist, that's reverse. Okay? All right, so you're going to put your transformation matrix B first. So you're going to have this is equal to 0, -1, -1, 0. All right, and then you're going to put the transformation matrix A, which is 0, -1, 1, 0. 0, -1, 1, 0. All right, we're going to perform matrix multiplication here. So as we know, rows in the first matrix multiplied by the columns in the second matrix. All right, so this is going to be equal to, now remember, this first row here controls the first row for the answer, and this row down here controls the second row for the answer. So this controls the top, this controls the bottom. Across here, this column controls the left, and this column across here controls the right. If we want our top left, we multiply this row by this column, top left. All right, so that's 0 by 0. All right, 0 by 0 plus -1 by 1. All right, if you want the top right, we're going with the top here with the right here. So 0 by -1 plus this -1 by 0. Then if you want to come down here, which is the bottom left, we'll have this -1 by 0. And then we have the 0 by 1. And then when we go across to the bottom right, that's the bottom here with the right here, because this down here is the bottom right, we'll have -1 by -1 plus 0 by 0. All right, so this is what t is equal to. All right, so working that stuff out, we have 0 by 0 is 0. -1 by 1 is -1, so you get plus -1. Across here, 0 by -1 is 0. And -1 by 0 is also 0. Down here, -1 by 0 is 0. And of course, 0 by 1 is 0 as well. And here, -1 by -1 is +1. And of course, 0 by 0 is 0. So t is going to be equal to this, so let's get -1. This is 0. This is 0. And this is 1. And this will be a transformation matrix T, which represents the transformation A followed by B. All right, so moving on to part 3, they want us to describe geometrically the transformation represented by T. So if you look here, the transformation represented by A was a rotation of 90 degrees anticlockwise about the origin. The transformation represented by B was a reflection in the straight line with the equation y equal -x. So that's what they want. So what transformation does this represent? Now, these are things you have to learn off, right? So this will represent a reflection in the x-axis, okay? So my answer, this transformation T represents a reflection in the x-axis. All right, so moving on to part B here now, we have the 2 by 2 matrix C is defined in terms of a scalar constant K by C is equal to 3K64. Now we want to determine the value of K given that the matrix C is a singular matrix. So first we have to ask ourselves, what is a singular matrix? Well, a singular matrix, the determinant is equal to 0. All right, so what we're going to have is the determinant of C. Just going to put DETC is equal to 0. All right, so now what is the determinant of C? You have to take the product of the leading diagonal, which is this 3 and 4, subtract the product of the non-leading diagonal, which is a 6 and K. All right, so this 3 and 4 is the leading diagonal, and the 6 and K is the non-leading diagonal. So I'm just going to write that up here, that 3 times 4, which is the product of the leading, take away 6 times K, which is the product of the non-leading. And that must be equal to 0. So 3 times 4 is 12. Take away 6K is equal to 0. We carry across the 12, it'll turn -12. So -6K is equal to 0, take away 12. So -6K is equal to -12. The operation between -6 and K is multiplication. So when we carry it across, we'll have -12 divided by -6. So K is equal to +2. All right, and that's the answer. The value of K is +2. All right, so moving on to part C, which is the vectors question. We have in the diagram below, O is the origin, so that's the origin here. OX is equal to U, so O to X is equal to U. So X is right here, not all the way up. All right, so that's from O to X is U. And we have O to Y is V. So this is O to this point here, Y is V. So we have OX and OY are extended so that X and Y are the midpoints of OA and OB respectively. All right, so X is the midpoint, the halfway point from O to A, and Y is the midpoint, the halfway point from O to B. So all this means is that from O to B, if from O to Y is V, then O to B is just 2 times V. If O to X is U, O to A is just 2 times U. Here I want to express bx in terms of u and v. So that's from b to x. All right, so let's draw a line connecting b to x. And I put the arrow going in this direction because you're going from b to x. That would see, right? See the arrow here? B to x, and the arrow going that way, right? From b to x. So b to x. All right, so as I said, this is u, so that's good. So o to y is v. So some o to b is 2 times v. Now, seeing that this is our resultant vector, we're going to use our triangle law, and we can see we have a triangle being formed here. So I know I need the vector b to o because this arrow points to the head, right? So this is the head of bx, and this is the tail of bx. So I need this vector that's going to come here. I need the tail to connect to the tail here. All right, so I drew the vector like this, the arrow going like this, because I need the tail of this vector to connect to the tail of my resultant vector. And of course, this vector is, well, going this way would have been 2v. All right, so if you're going the opposite direction, that's how you're using negative sign with vectors. All right, so going O to B is 2v. So going from B to O going to be negative 2v. So this vector is negative 2v. And of course, I'm going to go this way, which is what we have here, which is just u. This is going in the same direction as O to x, which is just u. That's the right over here, u. All right, so this vector b to x would just be negative 2v plus u. Or you can say u plus negative 2v, however you want to say it. All right, so that's going to write negative 2v plus u. All right, so my vector bx is simply equal to the vector b to o, all right, plus the vector o to x. Our shortcut as teach students is that if you want the vector b to x, the b must be at this end and the x must be at this end. And whatever in the middle must be the same letter. Okay, so it's in the o's in the middle. They are the same, and the b on this end and the x on this end. That's why you get b to x. So if you want to look at the diagram and figure it out like that, no problem. But I'll show you visually with the triangle law how to look at things. I'm just going to put these things here. So the vector o to b was 2v. So the vector b to o, which is the reverse of ob, that's why you're getting negative 2v. All right, so that's why b to o is negative 2v. Plus o to x, which is the u. And that's how we get our vector b to x. Now, if you don't like how this looks, you can write it the other way around and put the u first and then negative 2v after, and that'll be bx as well. All right, so that's to emphasize what went on here, that the tail of this vector here connected to the tail of the resultant, and the head of this vector here connected to the head of the resultant vector. And that's how you set up your triangle for adding vectors. All right, so going on to part 2, they have given that y to a and b to x intersect at M. So let's do that. All right, so remember we had bx coming here. All right, and what's going this way? Bx. And we have y to a. So that's y to a. All right, so this is vector y going to a. We've seen it intersects at M. All right, so M. All right, so that's part M here to mark this point of intersection here. And now we're saying that b to m is equal to 2 times m to x. So b to m, this point here, is equal to 2 times m to x. All right, so this is like a ratio. We can see that b to m is longer. So this is twice the length of m to x. So if this is 1 part, then this here is 2 parts. All right. So if you think about that, if here's 2 parts and here's 1 part, we have 3 parts in total. So this will be 1 out of the 3, and this from here to here will be 2 out of the 3. So what we can write is that m to x is equal to 1/3, which is 1 out of the 3 parts of the whole thing, which is b to x. Okay, and then from b to m, there'll be 2 parts out of the 3. of the whole thing, which is beta x. All right, so what do I want us to find? Bm in terms of u and v. So that's 2/3 bx. All right, so bm is equal to 2/3 bx. And remember, we found what bx was, right? If we go back here, bx is what? U take away 2v. All right, so that's 2/3 u take away 2v. All right, so if we expand, we could multiply 2/3 by u, and that'll just be 2/3 u. I multiply 2/3 by the negative 2v, and that'll be negative 2/3 multiplied by, put 2v over 1 like this. All right, so this remains the same, and this will just be 2 by 2v, which will give you 4v. So you get 4v over 3 by 1 is 3, so 4v over 3. All right, so bm is equal to 2/3 u take away 4v over 3, which we can write as 2/3 u take away 4/3 v. All right, so the last part of this question is to use a vector method, show that the ratio of ym to ya is 1:3, show all working. So let's determine what is y to m. So y to m is right here. And you know, if you want to find out what this vector is, you have to use the triangle law. So we need to form a triangle. So you can get a triangle right here, and we just found out what bm was. Okay? So this will be my resultant vector here, ym. So that's y going to m, like this. So my arrow is going like this, and this is my resultant vector. Then I need from here, this vector from here to here, I need the tail to connect to the tail here. And I need the head on this vector, which is b to m, to connect to the head here. So this vector y to b, I need tail on tail, so it will go like this. So the tail of this vector connects to the tail of my resultant vector. This is the vector that I want. And then going from b to m. All right, and that will go like this. Now remember, we found what bm was, right? Bm was 2/3 u take away 4/3 v. All right, so that was 2/3 u take away 4/3 v. All right, that's the vector b to m. And this vector y to b, remember, o to y was v, and y to b is also an xv. So this is this v here. All right, and that's because y was the midpoint of o to b. Right, so if here's v, from here to here, then here to here is also v. All right, so we have v plus this vector here, 2/3 u take away 4/3 v, would give you y to m. All right, so y to m is equal to yb plus bm. All right, and again, you see, you want y to m. The y is at the end here, and the m is at the other end, and the same letters are in the middle. All right, so yb is just v plus bm, which is this 2/3 u take away 4/3 v. All right, so your like terms will be the v. So this v is positive v. You can put together with this negative 4/3 v. So that'll be 2/3 u take away 4/3 v plus v. So now this is just negative 4/3 plus 1. All right, so okay, let's go on the calculator and put negative 4 over 3 and put plus 1, and we get negative 1/3. All right, so what we're going to get here is 2/3 u take away 1/3 v. All right, that's because negative 4/3 plus 1, because this is 1v, will give you negative 1/3. All right, so this is our vector ym. All right, so now let's work out our next part of the ratio, which is ya. So this is from y to a. All right, so my arrow will be going like this. And that's because it's going from y to a. So I can see my triangle could form with this side and this side. So I know this is my resultant vector. This is a tail of the vector, so I need the tail of this vector to connect to a tail of my resultant vector. So this is going in this direction v, So going the opposite direction will be negative V. All right, so I need to go in this direction. All right, so I need my arrow to go like this. All right, so this will be negative V. And then for my next vector, I need to go from O to A, which is 2 times U. And the arrow will go like this. All right, so you can see that this is my resultant vector. The tail of this vector connected to the tail of my resultant. The head of this vector connected to the head of my resultant. All right, so that's negative V plus 2U. All right, because from O to X is U, from X to A is another U, so the whole thing is 2U. All right, so this is 2U. All right, so I'm going to have Y to A is equal to Y to O plus O to A. Again, you see Y, A, see Y at this N, A at this N, and same letters in the middle. All right, so Y to O, we said O to Y is V, so go in the opposite direction, Y to O is negative V, plus O to A, and that's 2 times U. So if you want to write this the other way around and say 2U take away V. All right, so that's Y to A. All right, so looking at my two vectors, ym and ya, I noticed that here 1/3 is actually common to the two terms in ym. I'm looking at this ratio 1 to 3. I'm just going to say that ym, if I can fit it here, is equal to 2/3 u take away 1/3 v. I can factor out the 1/3. Open brackets, if I divide 2/3 by 1/3, I'll just get 2. So that'll give it 2u here. If you think about it, if you multiply this 1/3 by 2u, you're going to get back 2/3 u. All right, divide this 1/3 v by 1/3. The 1/3 cancels 1/3 and you remain with v. And notice that this 2u take away v is the same as this 2u take away v here. All right, so I just wrote over what ym was equal to. So we have the 1/3 times the 2u take away v. All right, that's ym. And of course, it came from this where I factored the 1/3 out. All right, and ya was 2u take away v. So we want the ratio of ym to ya. So ym is the 1/3 times 2u take away v to ya, which is 2u take away v. And now remember, we want to show that the ratio is 1 to 3 for ym to ya. All right, so ym to ya, you want to show a 1 to 3 ratio. So this side had to be 1 and this side had to be 3. So I can simply multiply this side by 3 to get rid of the 1/3. Okay, and whatever I do to one side, I'll do to the other side. So I'll have 3 times the 1/3 by 2u take away v to 3 times the 2u take away v. So 3 times 1/3 is just 1. So it's going to get 2u take away v to 3 times 2u take away v. And that's a ratio there. Well, 3 times 1/3 is 1, right? So I'm just going to put the 1 here so you can see the 1 clearly. And that's why you show the ratio is 1 to 3. All right, so I was going to put therefore the ratio of ym to ya is 1 to 3. All right, so moving on to question 10 for June 2021, we have calculated the product of these two matrices. Now, you know the order of a matrix is the number of rows times the number of columns. So this is a 2 by 2 matrix because you have 2 rows and 2 columns. And this here you have 2 rows, so this is a 2 by, and this have 1, 2, 3 columns, 3. Now, in order to know if these two matrices are compatible for multiplication, these two middle numbers needs to be the same. And the two end numbers will give you what the order of the answer will be. So the answer will be a 2 by 3. And because these two middle numbers are the same, you can multiply these two matrices. All right, so as we know, we multiply rows in the first matrix by columns in the second matrix. All right, so for our answer, our first row will be controlled by this 5 and 4, and our bottom row will be controlled by this negative 3 and 2. On our answer, the left will be controlled by this column 2, 0. The middle will be controlled by this column 1, 3, and the end on the right-hand side will be controlled by the negative 4 and 6. So if we go into the top left, all right, so top left, that'll be 5 by 2 plus 4 by 0. All right, if we choose to go down and go the bottom left, which is the negative 3 and 2 by the 2 and 0, negative 3 by 2 plus negative 2 by 0. All right, so now come for the middle now. So we're going to the top with the middle. So 5 by 1 plus 4 by 3. Then come the bottom with the middle. So this negative 3 by 1 plus the negative 2 by 3. Now come across the top right-hand side. So top right-hand side, 5 by negative 4 plus 4 by 6. And then coming down now the bottom right-hand side, negative 3 by negative 4 plus negative 2 by 6. Okay, so we can these things out. 5 2s are 10, 4 by 0 is 0, negative 3 by 2 is negative 6, negative 2 by 0 is 0, 5 by 1 is 5, 4 3s are 12, 3 by negative 1 is negative 3, negative 2 by 3 is negative 6, so you can plus negative 6, so that just take away 6. 5 by negative 4 is negative 20, 6 4s are 24, negative 3 by negative 4 is positive 12, and negative 2 by 6 is negative 12, and you're going to add negative 12, so that's just take away 12. Okay, let's put an imply sign here. All right, so 10 plus 0 is 10, negative 6 plus 0 is negative 6, 5 plus 12 is 17, negative 3 take away 6 is negative 9, and negative 20 plus 24 is positive 4, and 12 take away 12 is 0. All right, so part 2 here, we're going to state why the two matrices in A part 1, which is up here, are comfortable for multiplication. So I already explained that. All right, I said this was a 2 by 2 matrix, and this was a 2 rows and 3 columns, so that 2 by 3. And because these two middle numbers were the same, that means it was comfortable for multiplication. All right, so what does that say? Remember, it was rows by columns. So this means that the number of columns in the first matrix must be equal to the number of rows in the second matrix. All right, so I have that the two matrices are comfortable for multiplication because the number of columns in the first matrix is equal to the number of rows in the second matrix. All right, so moving on to part B, we want to determine the inverse of this matrix. So first we need the adjoint of this matrix. So first we identify what is the leading diagonal, and the adjoint will be equal to your interchange the leading diagonal. So you can have negative 2 on top and the 5 below. And you change the signs on the non-leading. So negative 3 turns to positive and 4 turns to negative 4. Okay. Then you need the determinant, which is the product of the leading. So that's 5 by negative 2. Take away the product of the non-leading, which is negative 3 by 4. So 5 by negative 2 is negative 10. Take away negative 3 by 4 is negative 12. Two negative signs, and multiply them and get a plus sign. So negative 10 plus 12. So you will get a negative 10 plus 12. That's just positive 2. So the determinant is positive 2. So my inverse is just 1 over the determinant. So 1 over 2 multiplied by my adjoint, which is the negative 2 3, -4, and 5. All right, so I write that as a half times -2, 3, -4, and 5. And if you're multiplying by half, it's the same as dividing by 2. Which is the preferred way? I prefer to work this. Let's take this matrix and divide it by 2. So I have -2 over 2, -4 over 2, 3 over 2, and 5 over 2. And let's work it out from there. All right, but since I have the half here, I'll do it a half multiplied by -2 over 1, a half multiplied by -4 over 1, a half multiplied by 3 over 1, and a half multiplied by 5 over 1. All right, so here the 2's will cancel. So 1, -1, nothing cancels here. 2 into 2, 1, 2 into -4 is -2, and nothing cancels here. So I'll have here, this will just be -1. This will be 3 over 2, which is 1.5. And this will be just be -2. And this will be 5 over 2, which is 2.5. So this is my inverse. Yeah, that's right. -1, 1.5, -2, 2.5. All right, so moving on to part C, which is the vectors question. We have the diagram below shows triangle OAB, in which OA is equal to R. So O to A is the vector R, and O to B is S. So O to B is this vector S here. In addition, E is the midpoint of CD. So E is the midpoint of this line going from C to D. We have OC is 3/4 of OA. So O to C is 3/4 of O to A. And AD is 2/3 of A to B. All right, so for A to D is 2/3 of A to B. So we want to write in terms of R and S in simplest form an expression for C to D and of course part 2 O to E. So let's look at C to D first. So that's C to D. So that's going to be our resultant vector. All right, so I have my vector going from C to D. Now I'll look and see where I could get a triangle. And obviously triangle will be on top here. All right, so I'm going from C to A and then from A to D. All right, this is my resultant. So the tail of my resultant must connect to the tail of this vector here. And since this is going to be the head of the resultant, the head must connect to the head of this vector here. So I'm going to have C to A plus A to D. All right, so before I do anything, I need to know what is the vector C to A. Now we have O to C is 3/4 O to A. So if O to C is 3/4, then C to A is just 1/4. All right, so since O to C is equal to 3/4 O to A, that would imply that C to A, which is the remaining piece, will just be 1/4, because 3/4 plus 1/4 will get a whole. All right, or I can write it as O to A take away 3/4 O to A. All right, so that's just 1 take away 3/4, which is just 1/4 O to A. All right, and O to A is R. All right, so that's just 1/4 of R. All right, so that's C to A. And then we need to know what's A to D, and we see that A to D is 2/3 of A to B. So now we need to know what's A to B. So A to B, all right, so let's write that out. A to B, and we follow the simple rule. If you keep any same letters in the middle, we have what is O to A and O to B. All right, so we just have AO plus OB. All right, so A to B, the A at this end, the B at this end, and the same letters in the middle. Now, A to O is the opposite direction of O to A. So O to A is R, so A to O is just -R. All right, so this is just -R plus O to B is S. All right, so let's write that as S take away R, and that's A to B. All right, and A to D is 2/3 A to B. So AD is equal to 2/3 AB. So A to D is just 2/3 of S take away R. So that's 2/3 S take away 2/3 R. Of course, expand, right? 2/3 by S and 2/3 by negative R. And that's my vector A to D. So now when it comes to the vector C to D, which is CA plus AD, all right, so C to D is equal to CA plus AD. And again, we're seeing the C on this end and the D on this end, so that's why it's CD and the same letter in the middle. All right, so CA is a quarter R. All right, so that's going to be equal to a quarter R plus AD, which is this 2/3 S, take away this 2/3 R. So put in brackets, 2/3 S, take away 2/3 R. All right, so CD is equal to a quarter R plus 2/3 S, take away 2/3 R. Bring like terms together. So we have a quarter R, take away 2/3 R plus 2/3 S. All right, can you just go and calculate and see what's a quarter, take away 2/3. All right, so we have 1/4, take away 2/3. So a quarter take away 2/3 is -5/12. All right, so I have -5/12 R plus 2/3 S. All right, so you can write that the other way around and see CD is equal to 2/3 S take away 5/12 R. All right, so now looking at part 2, we're going to find the vector OE. So that's O to E. So let's draw a line from O to E like this. That's our resultant vector. Now, in order to form our triangle, we need from O to C. All right, and vector will be going this way. So that my tail of my resultant connects to the tail of this vector. And remember, O to A is R, and O to C is 3/4 of O to A. So O to C is just 3/4 of R. All right, so this is just 3/4 of R. And then we need a vector C to E. All right, and of course, since this is a resultant, the head must connect to the head of this vector. See, both point in the same direction, head connected to head. Now, E, as they tell us here, E is the midpoint of CD, and we just found CD. All right, so CE is a half of CD. All right, so let's take this, put it across here, and I'll write C to E is equal to a half of C to D. And we go back here where we found C to D as 2/3 S take away 5/12 R. Okay, so that's a half of 2/3 S take away 5/12 R. All right, so we're multiplying a half by 2/3. The 2 will cancel 2 and leave it 1/3. So that's 1/3 S. And a half by -5/12. Nothing will cancel, so the 2 will just multiply by 12, so you get -5/24 R. So this is C to E. All right, so now coming here for O to E. O to E will be this O to C plus this C to E. All right, so we have O to C plus C to E. And again, you can see that the O and the E is on the end and the same letter is in the middle. That's why we have O to E. All right, so O to C is this 3/4 R. So that's 3/4 R plus C to E, which is this 1/3 S, take away this 5/24 R. All right, so let's bring our like terms together. So I'll put the 1/3 S first. Take away 5/24 R plus 3/4 R. All right, so this will be O to E. I'll just go on the calculator and work out what is this -5/24 plus 3/4. All right, so I'm just going to put negative 5 over 24. And I'm going to add 3 over 4. And that's 13 over 24. All right, so we get positive 13 over 24R. Okay, and that's my answer for O to E. All right, so moving on to part D, we have the points O, Q, and R have coordinates 0, 0. So that's the origin O. Q is 5, 2, so 5 on the X, 2 on the Y, that's Q. And R will be negative 1, 4. So negative 1 on the X and 4 on the Y. So you want to write the vector OR as a column vector. Now, you just take the row here as negative 1, 4. All right, the coordinate of R. So that's going to write R is negative 1, 4. And to make it a vector O to R, just write it as a column, which is just put the negative 1 first, then the 4 like this, and that's a column vector. All right, so here they want to determine the length of the vector Q to R. So again, this would be Q to R here. The arrow will point this direction, Q to R. This vector here is pointing in the right direction. The head of this is connected to the head of my resultant. But the tail of this vector needs to connect to the tail of my resultant. All right, so this vector needs to go in this direction. Of course, this vector goes in this direction. All right, so first QR is equal to the vectors Q to O plus the vector O to R. And of course, Q to O is negative the vector O to Q. Well, negative sign multiplied by the vector O to Q plus the vector O to R. So the coordinates of OQ, that's O to Q, is 5 on the X and 2 on the Y. So that'll be negative sign by 5 on the X and 2 on the Y, like this, plus OR, which is what we just found here as negative 1, 4. All right, so that's multiplying negative sign by the 5 and negative sign by 2. So we have negative 5 and negative 2 plus negative 1 and 4. All right, so let's put QR here. And that's just equal to negative 5 plus negative 1 and negative 2 plus 4. All right, so that's negative 5, take away 1, because multiply these two signs, they got a negative sign. And negative 2 plus 4 is just 2. So that's negative 6 and 2. All right, two negative sign, add and keep the negative sign. So this is my vector QR. And of course, now the magnitude of that vector QR will just be the square root of the negative 6 squared plus the 2 squared. All right, so that's the X component squared plus the Y component squared. All right, so negative 6 squared is 36 and 2 squared is 4. So that has to be the square root of 40. Let's put units. All right, and this is the end of 2021. Let's move on to 2019. All right, so now moving on to question 10 for June 2019, we have part 1. We have A part 1 and then part A of that. We have find the matrix product of, well, the product of these two matrices here. All right, so as we know, we multiply rows in the first matrix by columns in the second matrix. So we just have 2 rows here by this 1 column. All right, so our answer for this would be this row will control the top, this row will control the bottom, and we just have 1 column for the answer. So negative 1 by k is negative 1 times k, which is negative 1k, plus the 3 by 5, which is 15. Now coming down, now we have the 4 times k, plus the h times 5. Okay, so this is equal to negative k plus 15, and this is 4 times k plus 5 times h. Now, part B of the question, they say, hence find the values of h and k that satisfies this matrix equation. So this is the same multiplication that we just did up here. And now we put it equal to 0, 0. All right, so that's going to imply that this negative k plus 15 and this 4 times k plus 5 times h is equal to 0, 0. So what we're going to have is that the negative k plus 15 is equal to 0, which is my first equation. All right, so what we could do is carry across the positive 15 or turn to negative 15. So we have negative k is equal to negative 15. Multiply both sides by negative 1, and we get k is equal to positive 15. So we have our answer for k. All right, so that's what this implies here. Negative k plus 15 is equal to 0. And same thing here. 4 times k plus 5 times h is equal to 0. So our second equation is 4 times k plus 5 times h is equal to 0. That's equation 2. And we found that k is equal to 15. So that's 4 times k, which is 4 times 15, plus 5 times h is equal to 0. 4 times 15 is 60, plus 5h is equal to 0. Carry across the 60, turn to negative 60. And we carry across the 5 now. 5 multiplied by h when I go across, turn to division. So it's negative 60 divided by 5. And h is equal to negative 12. Alright, so let's come across here and write answer. K is equal to 15 and h is equal to negative 12. Alright, so now moving on to part 2, they want us to use the matrix method to solve the simultaneous equations 2x plus 3y is equal to 5 and negative 5x plus y is equal to 13. So first we write this in our matrix form. So we write our coefficient matrix, which is the 2, the 3, the negative 5, and this y is 1y. All right, so we have 2, 3, negative 5, and 1. Then we write our variables, which is x and y. And then we write our answers here, the 5 and 13. All right, I'll say let A be equal to the coefficient matrix 2, negative 5, 3, and 1. And x be equal to xy. And b be equal to the 5, 13. All right, so what I'll do, I'll find the inverse of the matrix A. So first of all, I have to get the adjoint of A. So that's interchanging the leading diagonal. So this is my leading diagonal here. So I'm going to interchange it. So 1 comes on top and 2 comes below, like this, and change the signs on the non-leading. So negative 5 turns to positive 5, and positive 3 turns to negative 3. Then I'll find the determinant of A. So that's the product of the leading, which is 2 by 1. Subtract negative 5 by 3, product of the non-leading. So 2 by 1 is 2. Negative 5 by 3 is negative 15. So let's take away negative 15. 2 negative signs, we get plus sign. So we have 2 plus 15. So that's just equal to 17. So I have my determinant of A is equal to 17. So A inverse is equal to 1 over the determinant of A multiplied by the adjoint of A. So that's 1 over 17 times the adjoint of A, which is 1, 5, negative 3, and 2. All right, so if this is matrix A, this is matrix X, and this is B, what I'll have is AX is equal to B. All right, so if I multiply A inverse on this side times the AX, which is equal to multiply A inverse on this side, A inverse times B. Well, if I do to one side of the equal sign, you must do to the other side of the equal sign to keep things balanced. All right, what I could do is probably put this in a different color. All right, so you can see that you multiply both sides by A inverse. Now, when you multiply a matrix by its inverse, you'll get the identity matrix. So you're going to get the I times X. And of course, I need to multiply with A inverse times B. And of course, the identity matrix times anything will just give back the same matrix. All right, so X is the matrix XY, And this is A inverse, which is 1 over 17 times 1, 5, negative 3, 2, times B, which is 5, 13. So we're going to have 1 over 17 times, and we're going to have rows in the first matrix times columns in the second matrix. So we're going to have 1 by 5 plus negative 3 by 13. Then we're going to have 5 by 5 plus 2 by 13. Okay, so that's 1 over 17 times 1 times 5 is 5. This is 3 by 13 is negative 39, and we're going to add negative 39, so that's going to subtract 39 one time. 5 by 5 is 25, and 2 by 13 is 26, so plus 26. So that's 1 over 17 times, all right, 5 take away 39 is negative 34, and 25 plus 26 is 51. All right, so this is what xy will be equal to, and I'll go to the next page and continue this. All right, so we had xy was equal to 1 over 17 times negative 34 and 51. So this is equal to 1 over 17 multiplied by negative 34 over 1 and 1 over 17 multiplied by 51 over 1. All right, so we have 17 to 17, 1. 17 to negative 34 is negative 2. We have 17 to 17, 1. 17 to 51 is 3. So this is going to give us negative 2 and 3. And that was xy. So my answer, x is equal to negative 2 and y is equal to 3. All right, so moving on to part B, which is the vectors question. We have relative to the origin O, which is 0, 0. So that's the origin here. So if it was on the Cartesian plane, this would be the origin. The position vectors of the points A and B are OA, 9, 0. So we have the coordinates 9, 0 here, but as a vector, we have it as a column. All right, and OB, which is 3, 6. So the coordinates 3, 6 as a vector, we have it as a column matrix. All right, respectively. The points D and E are on AB and OA respectively. So D is on AB and E is on OA, such that AD is equal to 1/3 AB. Right? So from A to D is 1/3 the whole thing from A to B. And O to E is 1/3 O to A. So O to E is 1/3 the whole thing O to A. First, we want to find the vector AB. All right, so that's A to B. Now we have the coordinates, so we know it's O to A and we know it's O to B. Now it's very simple. I could do the triangle law here, but we could keep it simple. We're keeping the same letters together, meaning that AB is equal to AO plus OB like this. All right, so we keep the same letters together because we know it's OA, O to A. We have OA here. And of course, we have OB here. So we know it's O to B. All right. Bear in mind that AO is the negative of O to A plus O to B, like that. So write it in. So negative times O to A is 9, 0 plus O to B, which is 3, 6. All right. So that's negative 9, negative by 9, and negative by 0. Let's give back 0. And 3, 6. All right, so AB is equal to negative 9 plus 3 and 0 plus 6. So negative 9 plus 3 is negative 6 and 0 plus 6 is 6. So that's what AB is equal to. Now moving on to part 2, we're going to find the vector O to D. So that's O to D. So if we draw a line connecting O to D like this, put the arrow going this way, because we're going from O to D. Now we just have to choose how we want to form a triangle. Is either we want to use this triangle here, where we know is O to B, and we should know is this. All right, because we know from A to D, as we said here, A to D is 1/3 A to B. All right, so we can work that out. We can just use this smaller triangle down here and use from O to A and A to D. All right, so you go from O to A, the arrow will go in this direction. All right, from O to A, so that this is my resultant vector. So the tail of this vector connects to the tail of the resultant. So the vector that come in here, now the head must connect to the head of the resultant. So that'll be from A to D. All right, so we know from O to A is the 9, 0. We know from A to D is 1/3 AB. So that'll be 1/3. So AB was -6 and 6. So that's -6 and 6. All right, so AD is equal to, so you multiply this 1/3 by -6, so you can write this as 1/3 multiplied by -6/1, and multiply the 1/3 by the 6 here. So 1/3 by 6/1. All right, so you're going to have 3 into 3, 1. 3 into -6 is -2. 3 into 3, 1. 3 into 6 is 2. So we're going to get -2 and 2. That's AD. So now vector O to D would be O to A plus A to D. All right, so our vector OD is equal to O to A plus A to D. All right, again, you're seeing the O and the O on this end, the D on the next end, same letter in the middle. All right, so O to A is 9, 0, plus A to D, which is -2 and 2. All right, so that's 9 plus -2 and 0 plus 2. All right, so that's 9 take away 2, and this is just 2. And 9 take away 2 is 7. All right, so we have OD is equal to 7 and 2. All right, so now moving on to part 3, they want us to find the vector B to E. So that's B to E. All right, so I have a line connecting B to E, and the arrow is going in this direction. All right, I'll form my triangle right here. All right, so we know it's O to B, and then we need to know it's O to E. All right, so if this is my resultant vector, then this vector is in the wrong direction, so I need to switch that. So I need to go this way instead. All right, so I'm going this way instead. So this is negative O to B. All right, so this is negative O to B. So you see, this is my resultant vector. The tail of my resultant vector connects to the tail of this vector. And this vector that's going to come here to form the triangle, the head needs to connect to the head of the resultant. So I'm going to draw it like this. And it needs to go in this direction. And that's O to E. Now, if you recall, they gave us this information that AD was 1/3 AB and that OE was 1/3 OA. So O to E is 1/3 O to A. So let's work that out. All right, O to E is equal to 1/3 O to A. So that's 1/3, and O to A was 9, 0. All right, that's what you coordinate here, A, and just make it a column matrix. So that's just 1/3 by 9 and 1/3 by 0. We should know 1/3 by 9 is just divided 9 by 3, and you're going to get 3. So that's 3, 0. So that's O to E. And now we are dealing with this B to O. All right, so B to O is just negative O to B. All right, so that's negative, and that's what the coordinates of B, right? O to B, 3, 6. All right, so we make that column matrix, 3, 6 like that. Multiply negative sign by 3, -3, -6. And we're good to go there. That's B to O. So now when I say the vector B to E is equal to, we're going to add B to O plus O to E. All right, B to O plus O to E. And we have B to O is -3, -6, plus O to E, which we have here as 3, 0. All right, so we have B to E is equal to, we have the -3 plus 3, and then we have the -6 plus 0. All right, so -3 plus 3 is 0, and -6 plus 0 is just -6. And that's my vector B to E. All right, and this is the last question for 2019, which brings us to the end of this video.